3.5 inches, 89 millimeters between Soviet broad gauge and German standard gauge track. Helped starve 3 million German troops before Moscow in December 1941. Forced hundreds of thousands of soldiers into railway security duty instead of combat, and created conversion bottlenecks that stretched supply journeys from 4 days to 18. When Wehrmacht forces smashed across the Soviet border on June 22, 1941, they brought 3,000 tanks and a plan to reach Moscow in 12 weeks, but they had no solution to a railway incompatibility that dated back to 1843. Over 4 years, both sides would convert tens of thousands of kilometers of track, rebuild thousands of demolished bridges, and discover that the width of a human fist could determine which armies advanced and which armies sat idle, waiting for ammunition that never arrived. This is every Soviet railway gauge conversion technique used on the Eastern Front, and how an engineering decision made 98 years before the invasion helped break the largest military operation in human history. 3 million German soldiers poured into Soviet territory that June morning, and behind them stretched the longest supply line in military history. Operation Barbarossa wasn't just an invasion. It was a logistical equation that German planners had calculated down to the last ton of ammunition and liter of fuel. The equation assumed an 8 to 12 week campaign. Capture Moscow before winter. Force Soviet collapse. Convert the railways at leisure after victory. The entire German logistical plan rested on that assumption. In the first month, Wehrmacht spearheads advanced over 800 kilometers into Soviet territory. The Blitzkrieg worked exactly as designed. German armor raced forward, encircling Soviet armies, capturing cities, seizing vast territories. And every kilometer of advance made the supply problem worse. German Jacintrie. Logistics officers watched their supply lines stretch like rubber bands. The trucks that had worked perfectly in France began breaking down on Russian roads that weren't really roads at all. Initial German operations relied entirely on captured Soviet rolling stock, the trains and locomotives they seized intact in the first days of the invasion. Some Soviet railway workers, caught by the speed of the German advance, found themselves operating their own trains under German orders. But German planners had allocated minimal resources to gauge conversion. Why invest in infrastructure when the war would be over by autumn? That calculation would prove catastrophic. The trains the Germans hoped to capture never arrived. Stalin's orders, issued in the early months of the invasion, left no ambiguity. Evacuate or destroy all railway equipment in the path of the German advance. Nothing of value reaches the enemy. Soviet railway workers executed the order with desperate efficiency. They evacuated thousands of industrial enterprises and relocated them east of the Ural Mountains. Entire factories dismantled, loaded onto trains, and shipped to safety. The Soviet railway evacuation removed vast quantities of railway cars from German reach. What couldn't be evacuated was destroyed. Locomotives sabotaged with sledgehammers and explosives. Rolling stock set ablaze. Bridges demolished with precisely placed charges. Track infrastructure torn up or rendered unusable. German forces captured territories with perfectly good rails and absolutely nothing to run on them. In some sectors, Soviet railway troops worked under German artillery fire to complete demolitions. A German logistics officer in Army Group Center recorded his frustration in August 1941. The enemy leaves us nothing but the permanent way. No locomotives, no rolling stock, no functioning stations. We have conquered a railway system we cannot use. The Soviets had turned their own infrastructure into a weapon. The gauge difference was about to become a German nightmare. The German response arrived in the form of specialized units that would wage a different kind of war. The Reichsbahn, Germany's state railway organization, deployed Eisenbahnpioniere, railway pioneer troops trained specifically for track conversion. These weren't combat soldiers. They were engineers, technicians, and construction workers who understood that modern warfare moved on rails. The Germans developed three primary conversion methods. The first and most common, moving the inner rail 89 millimeters inward and securing it to the existing sleepers. This required specialized spiking equipment and precisely measured spacing tools. Every spike had to be removed. The rails shifted, new holes drilled in the wooden sleepers, and new spikes driven. The second method involved replacing the sleepers entirely with new ones spaced for standard gauge. More permanent, but far slower. The third technique added a third rail to create dual-gauge track that could accommodate both German and Soviet trains. Theoretically superior, practically rare due to material and labor requirements. German conversion teams worked to convert track as quickly as conditions allowed, though the pace varied enormously depending on weather, partisan activity, and available supplies. By the end of 1941, Germans had converted thousands of kilometers of track. It sounded impressive. It wasn't nearly enough. Converting straight track was the easy part. The real nightmare waited at every station, junction, and switching yard. These weren't simple rail lines. They were complex systems with multiple tracks, switching mechanisms, loading platforms, and signal systems, all built for Soviet gauge. Every captured railway station required complete reconstruction. Germans established Umspurbahnhöfe, gauge exchange stations, at major junctions where Soviet gauge territory met converted German gauge. 2. Methods dominated these conversion points. The bogie exchange process involved lifting entire freight cars with cranes, removing the Soviet gauge wheel assemblies, and installing German gauge bogies. The operation required significant time per car under optimal conditions. When cranes broke down or spare bogies ran short, that time doubled or tripled. The alternative was even slower. Transshipment meant manually unloading cargo from Soviet gauge cars and reloading it into German gauge cars. Every crate, every barrel, every piece of equipment handled twice by human labor. A single train could take an entire day to process. Major bottlenecks developed at Brest-Litovsk, where the invasion began. At Minsk, the first major city captured. At Smolensk, the gateway to Moscow. Delays at conversion points could reach 48 to 72 hours. Trains stacked up waiting for processing. Supplies that should have reached the front in days took weeks, and winter was coming. December 1941. German armies stood within sight of Moscow's suburbs. They had advanced over 1,000 kilometers in 6 months. They had destroyed multiple Soviet armies. They had captured millions of prisoners. And they were about to fail because they couldn't get enough bullets and fuel to the front line. German forces, before Moscow, operated at severely reduced supply capacity. The railway conversion effort collapsed under the twin pressure of distance and winter. Converted track behaved differently than original construction in extreme cold. Rails contracted at different rates. Joints failed. Derailments became routine. Every derailment required repair crews, spare parts, and time. German locomotives, designed for Western European conditions, failed catastrophically at minus 40 degrees Celsius. Water in boilers froze. Lubricants turned to sludge. Mechanical systems seized. Supply trains that should have required 3 to 4 days to reach the front, as they had in France in 1940, now needed 14 to 18 days. The Wehrmacht found itself forced to rely on horse-drawn transport for the final supply leg from railheads to frontline units. The Eastern Front relied heavily on horses for logistics. Ammunition rationing began in November. Fuel shortages immobilized entire tank divisions. When the Soviet counteroffensive struck in December, German units fought with whatever supplies they had on hand. The gauge problem hadn't caused the failure to take Moscow, but it had starved the offensive of the logistical support it needed to succeed. 1942 brought a new complication. The Soviets began pushing back. and every kilometer of recaptured territory presented them with the same problem the Germans had faced in reverse. Soviet railways ran on broad gauge. Liberated territories now had German standard gauge track. The Red Army needed those railways to sustain its advance. Soviet railway troops, organized under the NKPS, the People's Commissariat of Transportation, used similar conversion techniques to the Germans, but with different priorities. Where Germans had prioritized speed to support rapid advance, Soviets emphasized permanence. Soviet railway brigades often opted for complete track replacement rather than simple conversion, slower but more reliable. They tore up German converted track and laid new broad gauge rails. Military supply took absolute priority over civilian rail restoration. Towns might wait months for rail service to resume. The front line got rails first. Soviet railway troops deployed in substantial numbers to support the war effort. These units followed immediately behind combat forces, sometimes working under artillery fire. The conversion war had become a race run in opposite directions. Both sides struggled with the same fundamental challenge. Neither side solved it completely, but gauge conversion wasn't the hardest problem. Bridges were. Both Germans and Soviets understood that rivers presented natural defensive barriers. Every retreat included systematic bridge demolition. Thousands of railway bridges were destroyed on the Eastern Front between 1941 and 1945. Bridge reconstruction took 10 to 50 times longer than simple track conversion. A team could convert several kilometers of track in a day. A major bridge might take months to rebuild. The Germans deployed standardized Rüstungsbaubrücke, armament construction bridges, designed for rapid temporary replacement. Prefabricated steel components could be assembled on site. These bridges could support locomotives up to 80 tons, but they required heavy equipment to install, specialized engineering troops to assemble, and constant maintenance under use. The Soviets employed pontoon railway bridges for temporary crossings. Floating platforms supported rails that could handle locomotive traffic. Risky in high water. Vulnerable to air attack. Better than nothing. Major river crossings became multi-month reconstruction projects. The Dnieper, the Don, the Volga. Each crossing represented a logistical choke point that limited everything behind it. In some sectors, bridge bottlenecks proved more significant than gauge conversion in limiting supply flow. German armor could race hundreds of kilometers forward, then sit idle, waiting for a bridge to be rebuilt so fuel trucks could cross. The converted track existed. The bridges were rebuilt, but there was nothing to pull the trains. The locomotive shortage became the crisis within the crisis. Germans had assumed they would capture Soviet locomotives and press them into service. Stalin's evacuation order eliminated that possibility. What few Soviet locomotives the Germans did capture presented their own problems. Soviet engines required different grades of coal than German locomotives. Maintenance procedures differed. German railway crews, trained on standard gauge engines, struggled with broad gauge, captured equipment. German locomotive production during the war years couldn't keep pace with Eastern Front demands. Production struggled to meet the demands of the Eastern Theater. Losses exceeded production. Partisan attacks destroyed locomotives in rail yards. Soviet air raids targeted locomotives specifically. Mechanical failures under extreme conditions removed engines from service. German railways faced severe locomotive shortages. Having converted track meant nothing without engines to use it. Supply trains sat in stations waiting for locomotives that never came. The gauge problem had revealed a deeper truth about industrial warfare. You couldn't conquer your way to adequate logistics. You had to build it. The Soviets had another weapon. Soviet partisan groups received explicit orders to prioritize railway sabotage. Small teams operating behind German lines could create damage far beyond their numbers. Common techniques included rail removal, simply unbolting sections of track and carrying them away. Explosive charges placed on converted track sections. bridge demolition using captured German explosives. The converted track proved more vulnerable than original construction. German conversion work, done rapidly under pressure, lacked the structural integrity of properly laid rail. A small explosive charge could damage converted track more effectively than original Soviet construction. Single partisan attacks could disable rail lines for 24 to 48 hours. Every attack required German repair crews to respond. Every repair crew needed security. Germans deployed substantial forces for railway security duty. Hundreds of thousands of soldiers who could have fought on the front lines instead guarded rail infrastructure. Partisan railway attacks increased dramatically as the war progressed. The multiplication effect was devastating. A few hundred partisans could tie down thousands of German troops. The gauge conversion effort required constant German presence to maintain and defend. Every kilometer of converted track became a liability that drained resources. 1944 reversed everything. German armies retreated westward under relentless Soviet pressure. And as they retreated, they destroyed the infrastructure they had spent 3 years converting. German demolition doctrine during the retreat was explicit. Destroy everything that could aid the Soviet advance. Rails torn up, bridges demolished, stations burned. The Germans were destroying their own conversion work. The irony was absolute. Soviet railway troops followed immediately behind the German retreat. In some cases, Soviet rail workers advanced under fire, beginning reconstruction before combat units had fully secured the territory. The Soviets had developed rapid reconstruction techniques through necessity and experience. They could restore basic rail service within days of liberation. Not perfect, not permanent, but functional enough to move supplies. Forward. Soviets restored tens of thousands of kilometers of railway in liberated territories as they advanced westward. The gauge problem had completely reversed. As German forces retreated through Poland and into Germany itself, they found themselves unable to use Eastern European railways. The tracks they encountered were broad gauge, either original Soviet gauge or Soviet reconstruction. German trains couldn't run on them. The invasion of Russia had been crippled by gauge incompatibility. The retreat from Russia was crippled by the same problem in reverse. 89 millimeters had shaped the war in both directions. The numbers tell a story that individual accounts cannot. German conversion efforts over 3 years of work involved thousands of specialized troops and millions of man-hours. The Soviets countered with extensive conversion and reconstruction efforts by war's end. German and Soviet railway troops both numbered in the hundreds of thousands at various points. During the conflict, the gauge problem created significant logistical inefficiencies throughout the war. Converted track required more maintenance, suffered more failures, moved supplies slower. The gauge problem was never truly solved by either side. It was managed, endured, and worked around. But the 89 millimeter difference remained a permanent drag on operations. Every supply calculation had to account for conversion delays. Every offensive plan had to consider railway capacity. The strategic impact compounded over time. Early in the war, gauge problems were one factor among many. By late war, accumulated delays and inefficiencies had become critical. The railway gauge problem didn't determine the war's outcome alone, but it shaped every major operation on the Eastern Front. There was an alternative. The third rail solution offered theoretical advantages that seemed obvious. Install a third rail on existing track, creating dual-gauge infrastructure that both German and Soviet trains could use. No conversion delays, no bogie exchanges, no transshipment bottlenecks. Both gauge systems operating on the same track. The Germans understood this. They installed third rail on limited sections of track, mostly on critical main lines, where the investment seemed justified. Why so little when the advantages seemed so clear? Third rail required more materials than single gauge conversion, more steel, more spikes, more labor to install. Installation took longer than simply moving one rail inward. The mathematics were brutal. Third rail required approximately 3 times the resources of standard conversion for what post-war analysis showed was marginal improvement. Third rail maintenance proved more complex than single gauge track. More points of failure, more components to inspect, more repairs needed under combat conditions. Speed restrictions on third rail track reduced its efficiency advantage. Trains couldn't run as fast on dual gauge infrastructure. The theoretical solution worked in practice only under near-perfect conditions. Conditions that never existed on the Eastern Front. The obvious answer wasn't the real answer, because warfare doesn't happen in ideal circumstances. German military planners conducting post-war analysis identified railway gauge as a critical vulnerability, not the only factor in defeat, not even the primary factor, but critical nonetheless. Gauge conversion delays contributed directly to the failure to capture Moscow in December 1941. Supplies arrived too late. Ammunition stocks ran low during the crucial final push. Soviet defensive strategy had explicitly incorporated railway gauge advantage into planning. Stalin and Soviet military leadership understood that every day of German conversion work was a day Soviet forces could use to regroup, reinforce, and prepare counterattacks. German logistics never achieved more than 50% of planned capacity on the Eastern Front. The gauge problem was a major contributing factor to that shortfall. Other factors included partisan attacks, air interdiction, inadequate truck transport, and the sheer distances involved. But gauge incompatibility compounded every other logistical challenge. It was the problem that made every other problem worse. Russia's 1843 decision to adopt broad gauge, whatever its original engineering rationale, proved strategically valuable. Make invasion harder by ensuring enemy trains couldn't use Russian rails. 98 years later, that effect was validated in the most brutal way possible. The 89mm difference had helped break the largest invasion force ever assembled. The war ended, but the gauge difference did not. Post-war Eastern Europe retained Soviet broad gauge in areas under Soviet control. The gauge line became a Cold War boundary, as clear as any political border. Where Soviet influence ended, broad gauge ended. Modern European Union still contends with gauge. Incompatibility at borders with Russia, Belarus, and Ukraine. Current gauge change facilities at the Polish-Ukrainian border handle conversion using modern automated systems. Technology the Germans never achieved. Automated systems lift entire trains, swap bogies, and return cars to track with minimal human intervention. What took German crews significant time in 1941 takes far less today. Finland maintains Russian broad gauge as a legacy of historical Russian control. The only European Union country with a broad gauge system. A reminder written in steel of imperial history and defensive decisions made over a century ago. The 89mm difference remains a physical reminder of the 1843 engineering decision that shaped the 1941 to 1945 war. Railway gauge conversion on the Eastern Front represents the largest such operation in military history. Never repeated at comparable scale. Never likely to be repeated. Modern warfare has moved beyond railways as the primary logistics backbone. But for 4 years on the Eastern Front, 89mm mattered more than most people realized. That gap between the rails was wide enough to starve armies, delay offensives, and help determine which side would write the history. 3.5 inches. The width of a human fist. The distance that helped decide the Second World War,